back. In this video, we are going to migrate all the files from ADLS2 onto Snowflake dynamically. Just to give a quick recap, in the last video, we were able to migrate one of the CSV file, that is the production underscore culture.csv, into Snowflake. We have done this manually, and now we'll see how to do this dynamically. Just a quick review of our architecture. We'll be creating the table in the first step and copying into in the next step. So all we have to do is pass in the parameters dynamically and it will create and copy data at the same time. So to do that, let's go back to our Azure Data Factory and create a new pipeline. I'm going to clone this pipeline and edit it. We will have a similar architecture to how we did for SQL to ADLS2, where we have a lookup, which lookup gets a list of all the tables that are needed to be migrated, and then add a logic to just pass in that table name in the create table function and the copy table function. We'll keep the get list tables as it is and edit this for each. Click on the pencil icon, and we wouldn't need the copy data function for this, so we'll delete it. Before making any further modification, I'll give it a descriptive name like ADLS2 to Snowflake, and we'll do it for one table for our understanding purposes and leverage this for all the tables then. So the activity that we are going to use here is called as script activity. What this allows us is to do something similar to lookup, where we can execute queries on the backend. So we will execute queries on the Snowflake end. So imagine this as writing a query in Snowflake. So these queries that we manually wrote get executed on the Snowflake end, right? So we'll just write this over here so that Azure Data Factory connects to Snowflake, executes it, and brings the results back. So drag and drop it. Once it's here, go to settings. Uh, Even before that, give it a name. I'm giving it a name as execute Snowflake query. After this, go to settings and then select your link service. As you know, we are creating this for the first time, so we'll have to click on create new and search for Snowflake and click continue. Fill in your details. So few things here. To find your account name, you can go to your Snowflake and go to your worksheets. Here on the bottom, you'll see a drop down here. Hover over your username and then click on this copy account URL. That will give you the URL for your account. So copy and paste it over here and remove those extra strings here. And then type in your username and password and give your database name. In our case, it's lab work. And for the warehouse, you can see in your worksheets, you'll be assigned a default warehouse when you create your account for the first time. So it's compute underscore WH in my case. So type in the name and click on test connection. If everything's set up right, you should see a successful test connection here. Cool. So click on create. All right. So now you're able to execute queries on the Snowflake side. So you have a script option here where you can add dynamic content over here. Before jumping into this further, I'm gonna click on publish all so that we can save our changes. Okay, so looks like we need to specify something over here. So I'm gonna specify a dummy query. So if you remember, we've created our first table here. So just do a top 10 star just to save our changes. Then click on publish all and publish. A quick demo on script activity. So I've created a new pipeline by cloning the previous one and removed the other activities and just added the script activity. So now let's try to execute this query and see how it's executed on the Snowflake side. So I've clicked on debug. Meanwhile, we can go to Snowflake, go back to worksheets and click on activity. This is where we can see any active queries and their statuses. So if you see there, we've executed top 10 star from the user Datartic tutorials that we just configured from ADF side. And this should be successful. You can see its input and output. Perfect. So we'll delete this. All right. So before going into the migration, I want you to understand one concept where we have currently manually assigned the column names and their data types for creating a table. But we want to we want Snowflake to kind of identify the column name and its data type dynamically based on the file. So to do that, we have something called as infer schema. So if you go through the documentation, you'll probably understand in depth about infer schema. But an overview of this is something that it allows Snowflake to understand the schema slash the structure of a file. So there are many examples in the documentation that you can go through it. For our purpose, we'll get a copy of an example here as our files are staged as CSVs and create tables based on those CSV files. So what we will be doing is providing the location of the file dynamically by iterating to the list and then creating a table based out of this select star. And in the next statement, we'll be copying that file data into the table that we just created. So that's how we're going to do it dynamically for all the files. Let's copy this example and see how it's done for one table. So let's do it for our production underscore culture and specify the location of the file and the file format. So you can see it has able to successfully infer the structure of the file, indicating that it was able to identify three columns and their data types, their expression, and their particular file names. So in the next step, we'll create the table based out of this. Again, let's copy the example to create the table. I'll replace the location and file format again. And I'll give the table name as culture test. And let's execute this. And let's see. Perfect. So we were able to create this table structure just based out of this file. If you've noticed one thing, we see that the column names are given as C1, C2, C3. This is because of the file format that we have defined. We have skipped header by specifying it as true here or 1. So to fix this, what we have to do is comment out the skip header part and add the parse header option as true. Once we recreate our file format, we can execute the create table again and then view the structure. So now you see the column names defined properly. So as mentioned, we can execute the copy into command to copy the data into this, and we specify match by column name as case insensitive. Let's view our data. Perfect. So let's leverage this to do this dynamically for all the tables now. So let's copy these statements into our ADF and click on add dynamic content. So the first step will be to create the table, and then the second will be to copy it. So here, let's modify the file names to be dynamic here. Okay, so we'll use the concat function parameter here. So what we will be doing is using a concat, we'll concat our string and add the item dot table schema with underscore and then item dot table name, which ends with dot csv, to kind of generate our production underscore culture dot csv format. So we'll do that for create and we'll do that for the copy. So let's add a statement to use our lab work database and migration schema. Okay, so just a quick review. This looks good. Okay, let's debug this. So you'll see each activity being executed. You can also track it from going back to the activity tab and refresh this. So you can see it's creating each and every table. So we'll wait for everything to complete and get back with the results. You'll notice that most of our activities were successful, and if you faced an issue, the whole activity fails, resulting in a failure in the pipeline. So you can check that by clicking on activity status, which reorders the statuses, and you'll see a couple of activities being failed here. So you can check the input to see which query results an exact failure. You can see person CSV ingestion failed. You'll see few others. By ingestion, what I mean is we ingest the data into Snowflake. So to debug this, one good way is to again go back to the query history and find the queries that resulted in failure. You can trace it back again in the activity tab and apply filters like failures, something like this. So upon selecting any one query from here, you can further debug on what the issue is. So I've copied one file, for example, jobcandidate.csv, that failed when creating the table. So I tried to rerun this, and again, as you can see, it fails with a issue saying header is defined 4 columns while data contains 3 columns. So this gives me an idea as we might have 4 columns in header, but somehow the data has 3 columns. So I go back to our staging area, view the file, and check the data. So I see we have 4 columns here, and then see first column, second column is empty. This is the third column, and somewhere here we would have our fourth column beginning. So the ideal issue is when you kind of debug this file, you can also look at other examples where this query failed. For example, over here. So let me find a different example. Let's consider the error with the production underscore product model.csv. Let's copy this example and paste it in our Snowflake and try to replicate the error. So as you can see, it's a similar error that we face where the header defined does not matches with the data inside it. Another way to view the file data is through a direct query at our staging. So if I execute this, you'll probably see that we have 6 columns, and the first 6 rows seems to be fine, whereas in the seventh row here, at the product model ID 7, you see a discourse of uh, the values getting split into multiple columns, and it ends over here. What I mean by that is if you go to your staging area, search for the file, and click on view slash edit, you'll notice something here. Normally, the way we get our data from source is in quotes around a field. So what we have done here is, if you see the data, we have given an option in our Snowflake file format as field optionally enclosed by quotes. So let's go back to our file format real quick. So we have defined our file format earlier where we have defined field optionally enclosed by quotes. What it says basically is you can have a field that's enclosed in a double quote after your after your whatever delimiter you have set. In our case, it's comma. So what's happening is, let's study the error again. So found a character h instead of a field delimiter comma. So if, on line 8, so if you see over here on line 8, it's finding a h character here. This is because it's treating this field here, this string here as one field, and then it's expecting a comma here. So normally when you get data like this, you don't really expect data to be clean, right? So you have to define file formats based on how you get your data. And the best way that most of the companies follow is they do not use comma as their separator. They use either pipe delimited or tab delimited or whatever the other character you can put it over here. So we'll go with pipe delimited format so that we can avoid such errors. Let's see how it's done. So to convert your files into pipe delimited, what you have to do is go back to your SQL to ADLS2 pipeline and go to the copy activity. And in the sync dataset, we have to modify the comma separator with pipe. So just change this with pipe. and save it by clicking publish, and then execute your pipeline again. Click on debug, and you should see your pipeline running again. Once everything is completed and successful, you can go back to your staging area and just hit refresh here. And as you can see, we have converted our comma delimited to pipes. And now we'll have to modify our file format and ingest this again. So let's go back to our Snowflake. Let's create a new file format. Let's give the field delimiter as pipe, and we'll add another parameter here, escape and enclose field. And then this is the escape character that we are defining. And then our field optionally enclosed by stays the same. I've also added timestamp format as auto. So creating this again, and let's try to rerun the failed query. All right, so now you don't see that failure. So let's try to ingest the data. All right, perfect. So looks like everything is loaded successfully. Let's validate by querying the table. So the failure that we got earlier was on the seventh row, and looks like everything works as expected. So we can restart our ingestion from ADLS2 to Snowflake pipeline again. So let's go back to the pipeline. Let's hit debug and let the pipeline run. Once it's all completed, you might see a failure here. So you can again debug this by changing the activity status. Now I just see one query that failed here. So clicking on the dialog box shows the error here as non null JSON error. So this is because if a file is empty, we do not create a table using the info schema. So it throws an error when you do that. You can copy the query to replicate it. I've done that already. So as you can see, it's a empty file. You can confirm that with executing just the select statement here. And then you'll get an empty array here. So other than that, you can go to your lab work, migration, tables, and you should see all the tables migrated. Congratulations if you have made until here. In the next video, we'll probably see on some enhancements, maybe how to handle files that are empty or send out an email when everything is completed upon success or failure. So thank you for watching, and I'll see you guys in the next video.